Let us solve more problems involving inverse trigonometric functions. Find the exact value of r cosine of cosine negative pi over 4. Write your answers in radians in terms of pi. Since cosine negative pi over 4 is equal to square root of 2 over 2, why? Because the reference angle for negative pi over 4 is positive pi over 4. Then cosine pi over 4 is equal to square root of 2 over 2. The negative pi over 4 is located at quadrant 4. Then the value of cosine at quadrant 4 is positive. Substitute the value of square root of 2 over 2 instead of cosine negative pi over 4. Then we have r cosine of square root of 2 over 2. Then using the definition of inverse function, we can represent this as theta. Cosine theta is equal to square root of 2 over 2. The value of theta that will give us cosine theta equals to square root of 2 over 2 is pi over 4. Therefore, the theta is equal to pi over 4. And this is the final answer. How about this problem? Find the exact value of tangent r cosine 4 over 5. Represent the inverse function as any variable, and in this case, I will represent this as theta. So, let theta is equal to r cosine of 4 over 5. We can rewrite this problem as tangent theta. From the definition of inverse function, we can say that cosine theta is equal to 4 over 5. From here, we can get the opposite side of theta to determine the value of tangent theta. Recall that cosine theta is adjacent side over the hypotenuse or x over r. Using the Pythagorean theorem, x squared plus y squared is equal to r squared. Substitute x is equal to 4 and r is equal to 5. 4 squared plus y squared is equal to 5 squared. Then isolate the y. It will give us y is equal to 3. Then tangent theta is equal to opposite side over the adjacent side. And we know that the opposite side is 3 and the adjacent side is 4. And this is the final answer or the value of tangent r cosine of 4 over 5.